Welcome back to day 2 of the unit circle. All right, in this video, we're going to take a look at some basics of how we use the unit circle to find some trigonometric functions of specific angles. All right, so let's start today by looking at a right triangle in the first quadrant of the coordinate plane. And what we're going to do here is we're going to label the hypotenuse 1 because in the unit circle, right, it's always going to be 1. Then we're going to label the horizontal part of this, the bottom part of it, x, and the vertical part of it, y. So it says, what is the cosine of theta? Remember, cosine is adjacent over hypotenuse, right? So the cosine of theta would equal x over 1. In other words, x equals the cosine of theta. And it says, what is the sine of theta? Remember, sine is equal to opposite over hypotenuse. So sine of theta equals y over 1. In other words, y is the sine of theta. So that means when we're talking about unit circle problems, all of the coordinate points, x comma y, will be known as cosine theta comma sine theta. Super important piece of information right there. All right, here is the first quadrant that we learned in our last video. Okay, if you need a second to look this over or copy this down, whatever you want to do, you can pause the video at this point. But this is something that we should already know, and you should already have a copy of the unit circle ready to go. So now we're going to start looking at some problems. Here are some type of questions we're going to be looking at in this unit. Example 1 says, you may be asked, what is the cosine of 60? How would we solve this? All right, so our first thought should be, what is the coordinate point at 60? Okay, now if you don't know that off the top of your head, you need to know that soon. But if you don't know that, let's go back to our first quadrant. 60, the coordinate point is 1/2 comma root 3 over 2. So it's 1/2 comma root 3 over 2. We also just learned 2 slides ago that the cosine represents the x coordinate. So therefore, the cosine of 60 is the x coordinate of 60, which is 1/2. So the cosine of 60 is 1/2. Okay, fair enough, but what if the angle is not in the first quadrant? So another question here says, what about sine 225? Well, this is why we talked about reference angles earlier in this unit. For any angle not in the first quadrant, we need to use a reference angle. We should know that the reference angle for 225 is 45 degrees. The coordinate point on the unit circle at 45 degrees is root 2 over 2, comma, root 2 over 2. We also know that on the unit circle, sine is the y coordinate. We just learned that today. So finally, we know that 225 is in quadrant. We should know this. It's in quadrant 3. And in quadrant 3, the y coordinate is negative. So all that information tells me that the answer for sine 225 is negative root 2 over 2. Example 3. What if the angle is given in radians? That's no problem. So sample 3 says, what is cosine 5 pi over 6? For any angle not in the first quadrant, we need a reference angle again. We know that any angle on the unit circle that's something over 6, so pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, the reference angles for those is 30 degrees, pi over 6 or 30 degrees. We know that the coordinate point on the unit circle at 30 degrees, again, if you don't know this off the top of your head, you can use the first quadrant for now, but you do need to know this soon without looking at a unit circle. The coordinate point on the unit circle at 30 degrees is root 3 over 2, comma, 1/2. Remember that cosine is the x coordinate, And 5 pi over 6, that we know is in quadrant 2. In quadrant 2, is the x-coordinate positive or negative? In quadrant 2, since it's left, we know that the x-coordinate is negative. So therefore, the cosine of 5 pi over 6 is negative x-coordinate root 3 over 2. One more type of problem. What if the angle is not in any quadrant at all? What if it's on one of the axes? Well, that's too easy for us to even worry about. It says, what is sine of 3 pi over 2? All right, so we need to know that 3 pi over 2 is the bottom part of our unit circle. It's the negative y-axis. So the point down there is 0, negative 1. We also know that on a unit circle, sine is the y-coordinate. We learned that today. Therefore, sine 3 pi over 2 is negative 1. On our last 2 slides, there's lots of practice problems. I would highly encourage you to pause this video at this point. Try those 12 problems on your own. Come back and check the answers when you're done. Here are the answers to the first 6 practice problems, along with the reference angles written next to them. And the answers for the last 6 with the reference angles written next to them. That is it for day 2 of the unit circle. Come back next time for day 3 when we start looking at cosecants and secants.